Hi everyone, Vega here, and in today's video, another in our Let's Talk series, I thought it'd be interesting to have a look at some of the solar system extremes. I found this really interesting page here on Wikipedia. There's just so many different variations in the solar system, so I thought we should look through. So if we see here, obviously there's only one star in the solar system, isn't there, at least as far as we know. So we've got the Sun. And here we've got average density. It's quite interesting, isn't it? So we've got major planets. Obviously, I think it's quite a well-known thing that Saturn is very low density. But interesting, the Earth is actually the highest density of a major planet. That's something that I wasn't aware of. I always thought that Mercury was the more dense one. I think basically being a core of a rocky planet, really, Mercury. But no, apparently it seems that the Earth is the highest density, which I find quite interesting. So Io is the moon with the highest density, which perhaps doesn't sound all that surprising. Average temperature, I think there's a section on this. Let's have a quick look. Yeah, so if we see the surface temperature here, we did do a video, and I find this quite interesting because if we look down, obviously the temperature of Mercury on the day side, so it's all in Kelvin, unfortunately, but I mean, look at the difference there. Mercury in the shaded areas is actually really cold, and as we know that Venus is a very, very hot world, but again we've done videos before that shows that Venus, there is some degree of variation in the temperature. If we look at the top of Maxwell Montes, for example, it's almost 100 degrees, in fact over 100 degrees less than in the lowlands, so there is some degree of temperature variation on the surface of Venus. Not all that different to the Earth, really. I mean, 330 Kelvin to 184 in Vostok in Antarctica, which I think is about minus 90, isn't it? About minus 90 degrees Celsius, which isn't, again, if you look at 184 Kelvin and just 120 on Mars. So again, it's not all that different, is it? The coldest places on Earth aren't all that much warmer than the coldest places on Mars, which I find is quite surprising. And I always find it quite interesting as well that a warm day on the Martian equator is 293 Kelvin, so a nice sort of crisp 20 degrees. Don't forget your sunblock, of course, on Mars. You might need quite a lot of it, but yeah, Mars is, if it had a thicker atmosphere, it would probably be relatively habitable, wouldn't it? If we think that those temperatures are, despite its much thinner atmosphere. But anyway, the point I was trying to get to here is I mean, some of the other planets. But if we go down to Callisto, the subsolar temperature, which is the area under the sun, directly under the sun, perhaps on the equator, is 168 Kelvin, which is roughly minus 100 degrees Celsius, which we always think of the Galilean moons as being frozen balls of rock. And yeah, I know that minus 100 degrees Celsius is colder than anything we've got on Earth, but 184 Vostok Kelvin and 168, so it's not all that different, is it? The hottest possible region of Callisto is only just colder than the coldest possible region on Earth, which I found quite interesting. Again, Ganymede's only another 10 degrees down. Europa does get quite a lot colder. So I don't think, as long as we sort of appropriate clothing on the surface of Callisto, that the temperatures, I don't think it's really an issue with the correct clothing, obviously. Which is another benefit about Callisto. It's actually really quite an interesting place, isn't it, Callisto? I think it's been vastly underestimated over many times, because it's just been eclipsed by Ganymede in size and perhaps Titan in atmosphere and so on. But it's sort of Callisto is very much the jack of all trades of the moons, which for me makes it probably the most likely place we're going to go to after Mars. Perhaps Ceres, of course, as well. And Venus, but I actually think Callisto is right in our sights as human exploration of the future is concerned. Let's go back and have a look at then. So we've got some elevation here, which is obviously a height above or below the datum. The sun doesn't appear to have any elevation, which is quite interesting, isn't it? Presumably a star is It's more sort of a plasma stroke gas stroke liquid. It doesn't really have a solid surface to make elevation, presumably. 3 kilometers on Mercury, on Caloris, Montes. That's relatively high, isn't it? Although not that high, 3,000 meters. Maxwell, Montes on Venus is a very high mountain, 11 kilometers. So Mount Everest plus about 2,000 meters on top of that. Everest, of course, is another one on Earth. And then we look at Olympus Mons there, 27 kilometers it sticks out into the sky, which is just phenomenal. I always found quite interesting as well about Olympus Mons that let me see if I can find a Mars elevation map, because I don't know if anyone's ever noticed it, and perhaps I'm just getting ahead of myself here, but I always found it quite interesting that Olympus Mons, if you could imagine this as a sphere, is almost on exactly the opposite side of Mars to Hellas Planitia. So it's almost as if something smashed into Hellas Planitia and went right through the planet and then poked out on the other side to Olympus Mons. Let me see if I can find a video that might show that in a better light. Yeah, I think it's here. I think that what's going on here is I could be wrong, but I think this area here at the bottom right is Hellas Planitia. Well, it's a little bit difficult to tell on this, and then if we go all the way around the world, there we are, hey presto, right on the other side of Mars is what I think is Olympus Mons there. Again, I could be wrong with this, I don't have a map of Mars printed in my brain, but as I say, it's almost as if something smashed into Hellas Planitia at the bottom there, and then almost came out the other side. I don't know if I'm imagining it or not, but anyway, I've always found that quite interesting. Obviously, the gas and ice giants don't have elevation. The moon's quite high, isn't it? Not 11,000 meters, doesn't seem to have a name there. That's quite interesting, isn't it? Highest point on the moon. Let's just have a quick look at this. How odd that they've not named the highest point on the moon, because it's actually higher than Mount Everest equivalent on Earth. But really the one I wanted to look at was, that I found really is the Verona Rupes on Miranda, which are cliffs that are 20 kilometers high. Let's have a look if we see what we can find. Imagine being at the top or staring over the edge of a cliff that was 20 kilometers high. I just find that absolutely incredible. On Miranda, one of Uranus's moons. That's some concept art there. So yeah, I found that fascinating. Imagine jumping off the Verona Rupes, because obviously the surface gravity on Miranda is not very high, so it wouldn't be like a fall off cliffs on Earth. You could practically float down almost. I don't think the terminal velocity would be particularly fast, although again I could be wrong on that. I don't pretend to know much about how fast you would fall, because although the gravity is a lot less, presumably because there's no atmosphere, there's no friction or anything to slow you down, so it may be that you'd actually bang quite heavily into the surface of Miranda. I don't know, perhaps someone else knows better than I on that one. Most distant objects, so we just recently did a video on the Oort cloud, but I also found that fascinating as well, that actually the most distant objects we know of really in the solar system actually are comprised of mostly of stuff we made ourselves. I mean, Voyager 2 is the second most furthest thing we know of. The Great Comet is now in December 2021 is 258 AU away from us, and the only reason we know about it is because it was close in. We don't actually know of anything particularly in the Oort cloud, so perhaps check the video out if you haven't. But if you look, so these are the furthest things we know in our solar system, and I mean, of the top 8, 1, 2, 3, 4 of them are actually contraptions that we've made ourselves. So really, beyond the orbits of Pluto and Neptune, we really don't know that much, do we? Which I found quite interesting as well. It's sort of a commonly assumed thing that this Oort cloud exists, but we do have obviously evidence for it in terms of comets, but visual objects that we've seen, basically it's far out, and that's about it. And even that's not really anywhere close to where the Oort cloud should begin, which should be around 2000 AU, and this is only 132, so still very much up for debate whether there is an Oort cloud or not. So back to our list of solar system extremes. Actually, it says here the tallest mountain is on Vesta, one of the asteroids in the asteroid belt, which is quite interesting, isn't it? Let's have a look at Ria Silvia, it's called. Silvia, I've not heard of that before. I've not actually looked at it. Tallest mountains in the solar system. Central peak of Ria Silvia. So it doesn't seem to be fully sure whether it's a crater or a mountain. Tallest peak. I presume bits are on the rim of the mountain. Largest craters in the solar system. One on Mercury, Caloris, North Polar Basin. Well, that's on Mars. That's not confirmed. Utopia is the largest impact crater. Utopia Planitia. God, that must have been a big hit. That's where the Viking probe landed, actually. Estimated diameter of 3,300 kilometers. It's here, Utopia Planitia. Doesn't seem to say much about what hit, but that's obviously a very big crater. There's quite a few on the moon as well, isn't there? Impact craters, Mars again, Hellas Planitia, Mars, Mercury, Pluto, Sputnik Planitia Basin. So Sputnik Planitia they think is an impact crater as well. Yeah, Iapetus is the obvious one, isn't it? The Death Star moon. I mean, look at that. It really couldn't be any more close to the Death Star, could it? Actually, speaking of moons, I always think that the moons are skewed in our solar system in terms of moons, because we often talk about the Galilean moons and we talk about Titan. But the truth is, once you pass those moons, Jupiter really doesn't have much on offer. I mean, the next largest moon of Jupiter after Europa, which is the smallest of the Galilean moons, is tiny. The next largest after Europa is Amalthea, which is absolutely tiny in comparison. You've got Europa at 3,000 diameter, and then you've got Amalthea at just 167. So really, after the Galilean moons of Jupiter, there isn't really anything. Let's have a look at Saturn. So again, we've got Titan, but Saturn does have a few on offer actually. It's got Rhea, obviously Iapetus, Dione and Tethys. Enceladus is actually really quite small. I know we talk about it a lot, but it's really quite a tiny place, Enceladus. But those, the four sort of medium-sized moons of Saturn are certainly far larger than anything Jupiter has after the Galilean moons. And another one that often gets overlooked are the moons of Uranus, which I know they're not very well celebrated, but they're actually quite large. In particular Titania, which, if we look at this list of moons here, once we get past the Galilean moons and Titan, and obviously the moon of Earth, most of the largest ones after that are from Uranus. I always find that they get overlooked, particularly Titania, which it's thought that some of the moons have quite seasonal atmospheres as well that get reasonably thick. Obviously not thick in terms of Earth's atmosphere, but thick in terms compared to other bodies of the solar system, as the seasons change on Uranus, which also makes them quite interesting as well. Anyway, I think we're going to wrap up the video there. If you've got any other ideas, things we could have a look at, just basically talk off the cuff about things that are interesting in our solar system or in our universe, in our galaxy, let me know in the comments below. Don't forget to like and subscribe if you've not done so already. Look after yourselves, of course, and your friends and families, and I'll see you on the next one.